Assalamu alaikum. My name is Mostafa Hussein. Today I'll be presenting the calculation for loads and beams and the design of steel reinforcement for beams, and we'll be talking about the methodology of calculating the loads and steps of designing steel reinforcement. First of all, one of the methods we use to design for moment and the loads for the solid slab and the flat slab and the flat plate is the ACI tables. As you can see here, this is two of the tables for the solid slab used for the long direction, both exterior and interior beams. These are the two tables used for the short direction, also both exterior and interior beams to get the moment and the loads. Onto the flat slab, these are the ACI tables used, just like the solid slab, but since we only have edge beams here, there is only two tables, one for the long edge beams and one for the short edge beams. Also, the flat plate is just like the flat slab, where it's only for the short and long direction edge beams only. The second method we tried is the tributary area method, where we use the equivalent width from both sides to calculate the load on the beams. And here is how we classified our beams. And we had 8 different groups for beams for the tributary area method. One of them, 4 of them are in the two-way slab, which is a solid slab, and 2 in the flat slab and 2 in the flat plate. The ones in the flat plate and the flat slab are the exact same. Also, using the exact same classification for the beams used in tributary area method, we used the loads we got from the tributary area method to develop our moment envelopes and shear diagrams from Procon. These are the Procon flat plate and flat plate beams, and these are the flat slab beams and how the diagrams would look like. These are the solid slab for the exterior beams. These are the interior beams. After the steel reinforcement and the stirrups of the flat slab beams in the long direction, we ended up with the negative steel. We used 3 phi 22, and for the positive steel we used 3 phi 19. For the stirrups, we used the spacing of 155 millimeter between each stirrup. Keep in mind that this is all for the flat slab in the long direction. And again, for the flat slab in the short direction, we used, for the negative steel, 3 phi 19, and for the positive steel, 3 phi 19 as well. And we used 155 millimeter between each stirrup. For flat plate, we used 3 phi 25 for the negative steel, and we used 3 phi 22 for the positive steel, and for the flat plate in the long direction as well, we used the spacing of 155 millimeter between beams. And for the flat plate in short direction, we used 3 phi 22 in negative steel and 3 phi 19. And for stirrups, we used 155 millimeter as well. For solid slab exterior, we used 3 phi 22 for negative steel, 3 phi 19 for positive steel, and 155 millimeters as well. And it goes on. The same for solid slab throughout, except that there is spacing with 145 in the interior beams. And this is the solid slab detailings in long direction. This is the detailings in short direction for solid slab. This is the flat plate beam detailings in long direction, and flat plate detailings in short direction, flat slab beam detailings in long direction, and the flat slab beam detailings in short direction. That about sums my presentation for you, and off to my friend Salman, who will be presenting foundation.